Section 2.3, we're going to continue to talk about chemistry and how particles interact and how really the particles are moving. So if you remember in section 2.2, we talked about solids, liquids, and gases, and how the particles acted in solids, liquids, and gases. So in solids, remember, the particles were the closest together. In gases, they were the farthest apart, and in liquids, they were in between or intermediate. So we're really going to kind of study motion of particles here and how it works with solids, liquids, and gases. And when we do that, we have to talk about kinetic theory. And you're like, kinetic theory? What does kinetic theory mean? That's two words that are really sciencey, and I don't really like those words. Well, we talked about a little bit about a theory. A theory is an explanation based on observations of scientific observation. But what does kinetic mean? Well, kinetic energy is energy. Anything that's moving has energy, and that's kinetic energy. Kinetic means really moving. If you are moving, you have kinetic energy. If you're standing still, you have no kinetic energy. So kinetic really means moving. Kinetic's a real fancy word that just means moving. For example, there are doctors called kinesiologists, and what do you think they deal with? They deal with how the body moves, so they're going to study muscle and joint interactions. Like, how's your knee work? How's your hip work? All right, that's a kinesiologist. So kinetic means moving. Kinetic means moving. Kinetic energy is affected by mass. All right, the heavier you are, all right, when you move, you're going to have more kinetic energy. So if we compare in the NFL an offensive lineman to a wide receiver, right, wide receivers are obviously much smaller than offensive linemen. Offensive linemen are kind of big, round, stocky guys. All right, they weigh 300 pounds. Say a wide receiver weighs 200 pounds. Because that if they are running the same speed down the field, the lineman's going to have more kinetic energy because he weighs more. And we'll kind of talk about that when we get to the physical science part. But kinetic energy means moving. So then, what does the kinetic theory mean? The kinetic theory means all particles of matter, whether they're in solid, liquid, or gas form, are always in constant motion. So molecules are always moving. So the kinetic theory of matter, right, is molecules are always moving. They never stop moving. If they stop moving, we're going to have huge problems. And we'll talk about the idea of can they stop? We'll talk about that later. So kinetic means moving, and kinetic theory means molecules are always moving. When we talk about gases, right, how do gases act? Well, gases are always moving because particles are always moving. Gases are particles. Gas particles are always moving. In fact, you can't even see it, but the air, some gas particles can move up to 1,600 miles per hour. Kind of crazy when you think about that. And even though you can't see it, gas molecules are colliding. They're midair, boom, midair collision every single time. Just colliding all over the place. But remember, they're so small that you can't see it. What's important, though, is when they collide, they maintain the same amount of energy after the collision. So two of them collide and they keep going with the same amount of energy that they had, but they continue to move. All molecules are moving. So gases are just always moving, and they do collide, but they're always moving. If we talk about liquids, oh, sorry, jumped the gun. Continue to talk about gases here real quick. Because this constant movement of particles, gases fill any container. They fill the room, they fill the school, they fill planet Earth because air is a gas, Earth is a container. They are going to fill their container because they're constantly in motion. How are they in motion? They're just in random motion, just always moving. All right? Kind of like you guys when you're hopped up on sugar. You're just always moving. You don't know why you're moving. You don't know where you're moving, but you're always moving. Same thing with gas particles. Right? Sometimes they will collide and it's not a big deal. And that's kind of with gases. Let's jump to liquids. Liquids. Remember, liquids have a definite volume but no definite shape. So, liquid particles flow to a new location. So liquid particles are flowing. They're just even. They're just going with the flow. Liquid particles going with the flow. They take the shape of their container. In fact, liquid molecules, because they're closer together than gas molecules, have more attraction to one another. And this attraction to one another creates properties in certain liquids, and we will talk about those properties later when you take chemistry in a couple of years. But behaviors of liquids, liquids just kind of flow. All right. Then lastly, solids. Remember, solids are the closest together. Solids are the closest together of all the particles. Particles in a solid vibrate around fixed locations. So the molecules of a solid are so close to one another that when they move, they're not like gases and liquids where they're just kind of flying around. All right, we got gases going zoom, 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 zoom. They're flying all over. All right. Gases are flying all over. Liquids are kind of, they're kind of just going with the flow, easy and mellow. The only way solids can move is they can vibrate. They can go, all right, all they can do is shake back and forth. They're kind of stuck. They're so close together, all they can do is shake back and forth. So gases are just zoom, 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 zoom. They're flying all over the place, molecule-wise. Liquids are just kind of like, hey, yo, dude, I'm just going with the flow. Because they're intermediate, and all solids can do is vibrate back and forth. All right, they're stuck in place, so all they can do is vibrate back and forth. And this is kind of the behavior of how solids, liquids, and gases act. So they don't really have a choice. They're kind of stuck. Solids are stuck. Liquids are just going with the flow. And solids are just flying all over the place. Or excuse me, gases are flying all over the place.